Hey, hello guys, welcome to Network Beats. This is Tangadurai, and in this video, we are going to discuss and trying to implement about BGP, a media attribute, also known as multi-exit discriminator attribute, and this feel interesting while doing the lab. So what I have done, so I haven't used my the previous topology what it is here. So in order to explain few things about the MED, so it was not finding suitable for me. So I have created the new topology and I have already pre-configured the IP addresses, and also I have set up the BGP neighborship relations between the routers as per this topology. So that is a basic thing that you can follow if you have seen my previous videos. So in this particular topology, we are going to try to configure MED, and we are going to experience how the functionality of that particular attribute is. So why? Because that means here we have AS 62510 and ISP1, ISP2, which is AS 600 and 800, and also we have AS 700, which is consider as our server form, okay, where we have it is not a real server form, just as a virtual thing I have put up here. Just assume that we have the users sitting in AS 62510, and where the traffic from AS 62510 is going to reach AS 700 through either ISP1 or ISP2. All right, so this is what about this particular topology is. So here we are going to make use of the MED to do the path manipulation, and how we can do that. So this I have split into two different parts because one thing we are going to play internally within AS 62510, and the next thing we are going to play between ISP1 and ISP2. Okay, so let's get into the first part. So here we have R1, R2, R3, R4, and R5 in AS 62510. So here, whatever the traffic comes to R1, okay. Before get into this, let me just clear few things, because I have got this doubt from few of my students, because it was not much clear about the previous attributes what we have looked, right? So till now we have seen about weight attribute, right? Second, we have seen a pref local preference, and third we have seen AS path perpending, right? So basically, and fourth, we are going to see about the MED, also known as a BGP metric. So this weight and local preference, this is these are the attributes will tell you how to exit from your local AS. That means, let's say this is your own AS, and you have multiple AS to reach to go to your destination, right? So how you want to exit from your local AS, that will be defined by these two attributes that we have seen in our previous video. And how you want to receive the traffic to your local AS will be defined by these two different attributes, which is either you need to use AS path prepending, or you need to use the MED attribute. So this is how these attributes functionalities are defined. So let me just repeat it. Weight and local preference will tell you how you should go out of your AS, whether you want to use this path, or you want to use this path to reach your destination. So for this particular objective, you can use weight or local pref, or if you want to define how the traffic should come into your network, right? So this is your source, right? So you want to receive the traffic in some predetermined way. That means like I don't want to receive traffic through this particular neighbor. I should receive traffic through this particular neighbor. If you want this particular scenario, yes, you can go on and implement AS path prepending or MED as per our topology scenarios. Okay, hope this is clear, and let's get into the MED part. When I'm talking about MED, here, okay, let's consider one about this particular topology. Okay, this R1 can receive the traffic whatever coming into AS62510 either via R2 or via R3, right? These are the only two ways. Okay, so what we can do for time being, okay, first let us see which is a preferred path by default. Let me go to R1 and let me see show IP BGP summary. Let me look into my BGP neighbor status. I have two neighbors and both are up, and I am receiving this many number of prefixes. And let me just give show IP BGP table to see which is my primary path comparatively R2 and R3. So here we can see R okay, let's see the traffic which is coming in, let's say 7, 6, 8. You consider any of these prefixes, whichever it is fine. I haven't applied any kind of route map. It is just simple plain fresh BGP config. Show run pipeline section BGP. Let's see what is the config over there. And this is what it is. Okay, so let me just remove this. This is not require because there is no route map. I have already removed it, but I forgot to remove it from under BGP. So what we can do it here is, yeah, as simple as that. So let me clear IP BGP star soft. It will clear both inbound and outbound. Let's look into our BGP table, and okay, these are here 6, 7, 8 prefixes which are coming in to our AS62510. So here for 6, 7, 8, the best path is via R5. Yeah, that is how it is learning. And in order to choose, let's say, trace route, let me give 77.77.77.77 with source loopback 0. I'm trying to trace route and I'm just analyzing which path it is taking. Since we are using EIGRP internally in AS62510, it is preferring both a path. Okay, why? Because it is a EIGRP, in perspective of EIGRP, this is equal cost load balancing is happening. Since my topology is like that, it is having the similar bandwidth links and similar hops, so the delay, load, reliability, whatever it is considered in composite metric calculation, everything will be the same. If you see that show IP route EIGRP, all right. So R1 to R4, to reach R4 we have two routes, right? Because we have the feasible distance is same, which is called as a composite metric as well, right? So the EIGRP distance is same in both the routes. That is why it both the routes are getting installed in the routing table, and that is why we are seeing the path is sorry, our packets are getting load balanced. Okay, so first let us fix that. What shall I do here? Let me go to any of the interface. Let me gig 2 slash 0, right? Let me go to gig 2 slash 0 and let me just increase the delay to, let's say, 200. Okay, so that this load balancing will not be happening, so that like as of now it is confusing which path it is taking, because whenever we do path manipulation using the MED, we should know like exactly which path is going to take. So in this scenario it is just going to do load balance each and every time. Let's see what is happening here now. So let me do the trace route again. Okay, it is going via 2 4 5 6 7, which is, it is going like 2 4 5 and 6 and then 7, right? This is how it is going. So let's say this is our primary path, and once this path is not available, then it is going to prefer this path. So what shall I do? I'm going to manipulate this default behavior, and I'm going to make use of this path as my primary path and the default one as my secondary path. So what I can do, let me go to router 1 and simply let me configure a route map called route map. Let me give a name something like metric, or okay, for AS62510. Okay, and let me give the permit statement and then the sequence number, and here I'm going to set metric, let me give 4545, which is easy to remember, and it is easy to look into that BGP table what we have set. So that's it, we have defined the route map and we have to go and apply that into our BGP configuration, right? So router BGP, what's our AS number? 62510. Okay, and the question is now, for which neighbor we have to set this route map, right? So the answer is, as per our topology, as per our criteria, we have to choose this. This is our primary path, and we have to make this the default path as my secondary path, right? So metric, how the metric works, right? So the metric, let's say, before getting into this concept, it is the simple one, right? The lowest metric is the more preferable one. Let's say I have a point A here and I have a point B here. To reach from A to B, let's say I have three different paths, and the first path, it is just taking me 5 minutes to reach B. Let's say the A to B, the second path, let it take 15 minutes to reach the destination, and the third path, let's say it takes 30 minutes to reach my destination. So which path does anyone choose to reach from A to B? Obviously the path which is having the lesser time, that we will be choosing, right? So this is having the less time over this path, so we will be choosing this path. So similarly the cost, or similarly the metric will work in the similar fashion, right? So when the metric is low, we'll be using that particular path as a best path comparatively the others. So here we are just going to apply this highest metric weight on, sorry, not weight, the highest metric value on the opposite side, where we do not want to use that path as a primary path. So this is our primary path. So I'm going to apply this metric route map for this particular neighbor, so that the metric will be set higher to my neighbor R2, so that whatever the traffic comes through R2 will be ignored, and router 3 path, the traffic coming through router 3 will be preferred to reach R1. Hope this is clear. Let's go and apply this. So do show IPBGP summary. These are the two neighbors that I have, and I'm going to apply this route map to my neighbor R2, and R2 IP address is, neighbor address is neighbor 12002, and the route map, and the route map what we have created And the question again here, whether we have to make it as an inbound or outbound. Okay, remember guys, whenever you want to do something to influence your incoming traffic, you have to apply the route map in the outbound direction. Okay, uh, if you want to do the vice versa, let's say you want to influence your outgoing traffic, let's say how you want to go outside of your local areas, then you have to apply the route map in the inbound direction. It is quite opposite to that, how you want to apply it. So here we are applying MED to influence our incoming traffic, how we should receive the traffic, right? Here, my objective is I don't want to receive traffic to R1 via R2. I want to receive the traffic via R3, right? So let's go to R7 and let me just show you the trace route to R1, which is 1.1.1.1 with source loopback 0. For time being, it is going through R2. I don't want to see this, right? I want to see it should go via R3. When this path is not available, then it is good to choose R2. But R3 should be my primary path, not R2. So this is what I want to change by doing this configuration. So let's get back to our work. Now in R1, what I'm going to do, like I said, I'm going to influence the inbound traffic. So I'm going to apply this route map in outbound direction, right? So hit enter and let's do clear IP BGP star soft. Okay, and let's check the traffic now. Also, let me go to 7. Before directly going into 7, first let us verify whether this particular metric value is being added to our neighbor tables. Okay, so when I set this metric 4545, right, if I'm not wrong, yeah, 4545. So let's give show IP BGP on R1. You're not going to see anything on R1, okay, because you have set this metric value in the outbound direction. So this update will be effective to your outbound neighbor. So where you have applied it from R1, you have applied it to R2. So go to R2 and see the BGP table of the R2, show IP BGP. Here we are going to see that 4545, right? So router 1 is advertising. Okay, you have to be clear on one more part. So whichever the prefixes are advertised by R1, it is going to set that particular prefixes with the metric 4545, not for everything. Okay, so here you can see whichever the next top or whichever is coming from R1. So R1 is advertising 1.1.1.1 prefix and 11.11.11.11 prefix. How do I know that? Just go to R1, type show IP BGP neighbor, and your neighbor IP is 12.0.0.2, and just give the advertised routes. Okay, so these are the two networks that I'm advertising to my neighbor. Okay, you are not saying anything related to metric over here. Okay, as of now, but it will be sent through our BGP update, and our router 2 is receiving with the metric value of 4545. So for these two prefixes, we are seeing this metric value, and you can see in order to reach for this network, the best path is via 13.1.1.1, right? Not via 12.0.0.1. It is saying that this is not the right link to get to that network. Instead, R2 is suggesting to use this particular path. So that is what it is showing here, right? So star and the greater than symbol. Star is a valid path, and the greater than symbol is showing us which is a best path. So here there is no greater than symbol, which is via the directly connected link to R1. Here it is the alternate path via R4 to reach R1. So this is same for 11 prefix as well, right? So if you go to R4 and check show IP BGP, you won't be seeing this 4545 because whenever you set a med or metric, this will be only applied on the next hop neighbor router only. That particular value will not be exchanged with any other router. Okay, so that means R2 know that R1 the metric value of 4545, but R4 never know that uh, this 4545 metric has been set from R1 to R2, because if you see here in R4 we are not seeing the metric value of 4545, we are only seeing on where in R2. So whenever there is a prefix comes into R2 to reach the destination prefix of 1.1.1.1, it is not going to prefer the directly connected link. Instead, it is going to just reroute via this particular path. So that is how it is going to work. And if you want to know, let's type show IP route 1.1.1.1. Okay, it is learning via BGP, and my the next hop will be 13.0.0.1, right? It is not 12.0.0.1. Okay, this is how you can verify it. Now let's go to server form and let's do the trace route again to 1.1.1.1, and let's see whether it is going to be the same or it is going to be different now comparatively our previous output. So see here, this is a clear cut confirmation for us. The path is not going via R2 because it is going to R4, and from there it is now taking a path through R3 and it is reaching the R1, right? So this is how that you can influence your traffic when you are in an inside any autonomous system number, when you have more than one path, and if you want to choose one path over the other paths, then you can do this by doing by configuring the MAD. Okay, so this is how you can influence your incoming traffic. This is the part one I have told. Let's go back to our part two, what I'm supposed to do with our ISP. Okay, so let me just remove this configuration with R1 and let's make it default. Okay, it is nothing, there is nothing wrong with that. If we keep, that's fine. So what we can do now, let it be. So let's say R7, right? This is our destination because the users from AS62510 is trying to reach the services which are served from AS700, right? So I have, being a network administrator, I have a control over AS62510 and AS700. Okay, because I'm the network administrator of that particular ABC company and I have the control over there to configure or to monitor or to optimize my network. But I do not have any control on AS600 and AS800, which is my ISP network where I am peering with to get connected between my two different AS. So let's say ISP, okay, before doing anything, let's go to R7 and let me see. So by default, it is taking R6 path, right? It is through router 6, it is trying to reach AS62510. That means to reach my R1 prefixes. So what I want to do, let's say this ISP1 is intimating us we are seeing some degradation issue in our network. So we are going to do some upgrade on our router. So for so and so time period, this particular link may not be 100% feasible to carry the traffic. If there is any losses, it is already new one. Okay, that means it is known issue. Okay, So do not worry about this. So it is okay with that ISP, but what if, because it is affecting our productivity, right? So whatever the upgradation they are doing. So what I'll do, we should cost out this link. That means we should not be using this particular connectivity until the maintenance work get over with ISP1. So for time being, even though ISP1 is my primary link, I want to switch over my traffic from ISP1 to ISP2 so that my real-time traffic will not get affected because of the maintenance work which is being carried out by ISP1. Okay, so how we can do that? So in R7, we are just going to configure create a route map similarly how we have done in R1. Okay, so let me create a route map. In this scenario, okay, it is quite obvious, right? It is quite common to see or receive communication from ISP that they will be doing the maintenance, or they will be doing the service upgradation, or they will be doing the chassis upgrade, something like that. So let me create a standard template for each and every ISP so that whenever a ISP comes up with this particular plan, it is easy for me to go and switch over my traffic from one ISP to the another ISP. So let's create a default template. Okay, so let me create a route map. Let me give a name called cost out ISP1. Okay, that means I'm switching over the services from ISP1 to ISP2. And let me give the permit statement, and let me give the sequence number 10. And here I'm just going to set the metric. Okay, let's keep something which is easy to remember. Since ISP1 is part of a 600 and this is 700, okay, let's give like 600, 700, because the metric value, whatever you choose, that can be in the range of this. Okay, or you can do plus or minus with the existing metric. But let's do it in this way so that it is easy for us to remember which we are doing costing out, or which we are doing costing in. Costing in, costing out, if you guys are confused with that, means cost out means we are switch over from X to Y. Costing in means we are back, like we are roll backing our uh, cost out what we have done earlier. Okay, vice versa. So let's say set metric 600, 700, and exit. Now what I have done, this is my primary path for time being, because you can see the traffic, it is leaving through R6 from R7, right? So what I want to do, whatever the traffic comes in, it should not go through R6. Let's do in this way, because we are going to influence the inbound traffic, right? Let's also confirm from the R1 how the traffic is going to hit R7. Trace route 77.77.77.77 source loopback 0. So it is confirming that, okay, it is using R6 to reach R7, right? So that means this is what I want to change. Once I am done with my cost out, my path should be preferred over via R8, not via R6. So let's go back to R7, and what I'm going to do here, let us go to router BGP, and it is AS700. Okay, R7 is nothing but the server form. Okay, so you can see that here, don't confuse with the hostname. So now the question, okay, where I have to apply this particular route map, all right, to which neighbor? I'm going to cost out ISP1. That means I'm going to apply this route map to R6. So neighbor 67.00.6 and route map, I'm sorry guys, route map, and the route map what I have configured here is cost out ISP1. Similar fashion, again here we are going to configure it in outbound direction. So before doing it, let's go to R6 and see show why this is happening. Okay, show IP BGP. And here I do not see any metric value for timing. Everything is 0000, right? Okay, let's go and do this and let me exit. So clear IP BGP star soft. Also let me do the soft clear over R6 as well. Let me do show IP BGP now. The prefixes whichever is being advertised from R7 will have the metric value of 600 700, right? See 600 and 700. It is not only the prefixes whichever is being advertised from R7, also the prefixes whichever is being uh, it is not only originate from R7 because R8 is advertising the prefixes through R7. Even that will be let's say if it is a best path for time being, then even that particular prefixes will be included over here. So let's go back to R7 and see show IP BGP neighbor 67006 advertised routes. So these are the routes that I am advertising because BGP, let's say you are having three neighbors and your BGP router will only advertise whichever the best route and the valid route from their BGP table to their neighbors. So in this case, R7 is looking this many prefixes are best routes from the R7 and the valid routes from the R7 that is getting advertised to R6, right? So for all these prefixes, now we can see the metric value of 600 700 whichever we have set. So hereafter, whenever the traffic comes to R6, it is saying that even though I have the direct link connected to R7, okay, so fine, this is fine. Give me a minute. So ignore this. Let me come back to this. Let's go to R1 and let me show you trace route. Here we should not see that it is going via R6 and it should go via R8, right? And before doing that, let's also verify. Now I have set the metric, like I have set the metric to R6 from R7. We are able to see that metric value in R6, but that metric information is not being forwarded to R5, right? So that is what we have seen earlier also. R5 should not see those metric value that 600 700 for any of the prefixes. It is just local to that R6 only. So let's find. So R5's perspective, if R5 want to reach 77, it is still showing router 6 as a best path, not router 8. So this is wrong information. Let's do a clear IP BGP and let's try what is the status now. Clear IP BGP star soft. Okay, so for this, okay, it got changed. For this 7777, it is showing through R6. Okay, let me just verify it from R1. Okay, it is still showing through router 6 is the best path. Let me just verify the configuration. Sure and section BGP. Okay, everything looks good here. Clear IP BGP char. Let me do hard reset. This happens sometimes in the virtualized platform, but not happen in the real-time routers. Let me also hard reset on this edge routers R5 just to get the updated information. I haven't done any configuration changes. So let's go back to R6 and re-verify. Show IP BGP. Okay, still we haven't received these prefixes. Okay, let's go back to R5 and see how the R5 looks now. We haven't received the 7 network yet. Let us wait for some more time. Okay, it is received now. Okay, so let's get back to R5 and see what is the status here. It is not yet received. Let's wait. Okay, we have received it now. See here, we haven't done anything much before. So previously, where it is. Okay. Previously, this is what the output it was, right? So we have done the cost out to router 6, and even after doing that, the update was not triggered immediately because R5 was still seeing the best part through router 6, not through router 8. But after doing the hard reset, right, now the behavior got changed. Now actually it is taking for 77 network, it is taking the what R8 as a primary path. Let's go back to R1 and let give the trace route again. So this 6 would be changed as 8. Now our objective is being successful, right? So we have successfully costed out this particular link. So whatever the traffic is going to R7 is everything is going via R8, not through R6. And even if you're the reverse traffic, whatever you are trying to reach, your trace route 11.11.11.11, which is the router 1, even that will be sent via router 8. Okay, so router 6 is not used. So this is how that you can manipulate the the decisions, like the path. You can manipulate the path using the media attribute. Let's say after some time you want to do the same for R8. Nothing, you just need to do the same configuration, like not on R1, sorry, you have to go to R7 and configure terminal route map, create a different route map, or you can use the same route map and apply it over there. But in real time it will be confusing because you'll be having n number of routers and you don't know for which service provider you are trying to do cost out and for which you are not doing. That you should be assured. So if it is Airtel, if it is Vodafone, if it is AT&T, for each and every service provider, better to have each route map is pre-configured so that you can go and directly call that particular route map under the neighbor to cost out your services. So in this case, what I'll do, simple, cost out ISP 2 permit 10, and let's do set metric. It is up to you. I'm just choosing some fancy values just to for easy remembering. So here let me put as 700, 800 so that it will be understandable for us while doing the lab. So if I want to do this, show run section BGP. Simply what I'll do, I'll just let's say once this particular link is up, and let's say ISP2 is going under maintenance now, and we want to cost out that, and we want to cost in this ISP1, then we can do it by removing the exiting command, and let's cost out the ISP2 how we have done it previously for ISP1. So it is simple. Configure terminal, router BGP. So let me just uh, remove this, since since through router 6 is preferred as a default default exit path for the router 1, or to reach the router 7, router 6 is the default one to reach. So in this case it is not required to cross with the ISP2, but if you want just to be a safer side and you want to do that, yeah, still you can do that. There is no harm in that. But if you have three different links, and let's say this is a primary one, this is a secondary one, and you have the third link with some other ISP, let's say ISP2 is going under maintenance, and if you haven't do any cost out to ISP2, let's say that ISP1 got affected, or let's say ISP1 is flapping, okay, your services will automatically get switch over to ISP2. And if you didn't do cost out ISP2, by that time you will be facing some service issues, like it can be anything, right? So let's say in precautionary, if you have costed out that particular link, then automatically your link will be switched over, your services will be directly switched over to ISP3 whenever the ISP1 is facing any issue. So this is how that you can play with MED attribute. So I think hope this is clear for you guys, and let me know whether you have any doubts in the comment section. And if you like my content, just please like, share, and comment the video. Thanks for watching. Have a good day. Bye.